Finding the dynamic viscosity of a fluid. Understanding the dynamic viscosity of a fluid is essential for civil engineering applications, particularly in designing systems involving fluid flow. This brief study guide will explore the concept of dynamic viscosity, the forces involved, and how to calculate it, providing learners with a comprehensive understanding of this fundamental property of fluids. What is dynamic viscosity? Dynamic viscosity, often denoted by the Greek letter mu, is a measure of a fluid's resistance to deformation or flow. It quantifies the internal friction that occurs when layers of fluid slide past one another. In simpler terms, dynamic viscosity can be thought of as the thickness or stickiness of a fluid. Importance of dynamic viscosity in civil engineering. In civil engineering, the dynamic viscosity of a fluid plays a crucial role in various applications, including hydraulic systems, understanding fluid flow in pipes and channels. Soil mechanics, analyzing the behavior of saturated soils. Concrete technology, assessing the workability of concrete mixtures. The force required to glide the top slide over the bottom slide. To understand dynamic viscosity, we can analyze the force required to glide one layer of fluid over another. Imagine two parallel plates, where the top plate is moved over the bottom plate with a certain velocity. The force needed to maintain this motion is directly related to the dynamic viscosity of the fluid between the plates. Formula for dynamic viscosity. The relationship between the force, the contact area, and the dynamic viscosity can be expressed mathematically. The formula is as follows, where F equals force required to glide the top slide over the bottom slide, N. Mu equals dynamic viscosity of the fluid, Pa. A equals contact area of the plates, M superscript 2. V equals velocity of the top plate, Ms. D equals distance between the plates, M. Worked out calculation. Let's illustrate this with a worked out example. Example, suppose we have two plates with a contact area of 0.5 square meters, a distance of 0.01 m between them, and the top plate is moving at a velocity of 0.2 ms. If the dynamic viscosity of the fluid is 0.8 Pa, we can calculate the force required using this formula. Now substituting back into the equation. Thus, the force required to glide the top slide over the bottom slide is 8 newtons. Factors affecting dynamic viscosity. Several factors influence the dynamic viscosity of a fluid. Temperature. Generally, as temperature increases, the dynamic viscosity of liquids decreases, while for gases, it increases. Pressure. For most liquids, an increase in pressure results in an increase in dynamic viscosity. Composition. The molecular structure and composition of a fluid can significantly affect its viscosity. In conclusion, the dynamic viscosity of a fluid is a key property that influences various civil engineering applications. Understanding how to calculate the force required to glide one plate over another, along with the factors affecting viscosity, equips learners with the knowledge to apply these concepts in real-world scenarios. For further reading and scholarly sources, you can explore the following links. Dynamic viscosity and fluid mechanics. Fluid mechanics in civil engineering.